Welcome to the deep dive. Today we're going to be looking at some of your exam prep materials,
Yeah.
focusing on scientific research.
Absolutely, and how to make sure you can ace those exams.
Exactly,
Yeah.
to really understand all the key concepts and theories and all those
Definitely.
tricky definitions.
Yeah. We'll be covering the core principles of scientific research
Yeah.
and those tricky research designs
Yeah.
and even the concept of paradigms.
Okay,
Yeah.
sounds good.
Guess so.
And remember, this deep dive is brought to you by Grade Guru.
Right.
For practice exams and a complete rundown of all of these concepts, be sure to visit gradeguru.nl.
Yes.
Now let's kick things off with a fundamental question.
Okay.
What makes scientific research so unique?
That's a great question to start with.
How is it different from just relying on common sense?
You know, while common sense can sometimes be helpful, it's often based on personal experiences or biases or even just our mood at the moment.
Oh, yeah.
Scientific research, on the other hand, takes a much more systematic and rigorous approach.
Okay, so it's about having a clear structure and methods, not just
Precisely.
random observations or gut feelings.
Yeah. Think of it as a structured, logical, and constantly evolving way of building knowledge.
Okay.
It relies on a dynamic interplay of three key elements:
Okay.
theory, data collection,
Okay.
and data analysis.
Okay. I'm intrigued. Can you break down how those three elements work together?
Sure. Imagine you're a detective
Uh-huh.
trying to solve a case.
Okay.
Your theory is your initial hunch about who committed the crime.
Uh-huh.
You gather evidence, which is your data collection,
Right.
and then analyze that evidence to see if it supports your theory.
Okay.
So in scientific research, this process involves a lot of testing and refining to make sure our theories hold up under scrutiny.
So it's like a constant cycle of testing and refining our understanding.
Yeah.
It's not about proving ourselves right, but more about challenging our assumptions
Exactly.
and seeking the truth.
And that's where the principle of falsification comes in.
Hmm.
It's one of the cornerstones of scientific thinking, and frankly, it's kind of revolutionary.
Falsification.
Okay.
You've piqued my curiosity.
Mm-hmm.
Tell me more. What's so groundbreaking about this principle?
Well, instead of trying to prove a theory correct, we aim to disprove it.
Okay.
This might sound counterintuitive,
Yeah.
but think about it.
Okay.
If you only look for evidence that confirms your theory,
Mm-hmm.
you might miss crucial information that contradicts it.
So it's like deliberately trying to find flaws in our thinking.
Yeah.
That seems a bit tough on our egos.
It can be, but it's what keeps science honest and constantly evolving. Instead of clinging to potentially flawed ideas, we embrace the possibility of being wrong.
Yeah.
And that openness leads to more robust and reliable knowledge.
I'm starting to see how this can be a game changer, especially when studying for exams.
Absolutely.
But can you give us a concrete example of how falsification works in practice? I'm a real-world example kind of learner.
Okay, let's take the classic example of all swans are white.
Hmm.
For centuries, people in Europe believed this to be true
Mm.
because every swan they had ever seen was white.
Okay.
But then, guess
Yeah.
what? Explorers went to Australia and discovered black swans. That one single observation completely overturned a long-held belief.
Wow. That's a powerful illustration of how just one piece of contradictory evidence can shake things up.
Yeah.
So by constantly challenging our assumptions, we avoid getting stuck in potentially flawed ways of thinking.
Right.
It's like a mental reset button.
Absolutely. And this approach helps us avoid biases and build a more accurate understanding of the world.
Okay, that makes a lot of sense. Now, while we're on the topic of potentially flawed thinking, let's talk about those sneaky, spurious relationships.
Yeah.
What are they and why should we care, especially when it comes to exams?
Yes.
Yeah.
Spurious relationships are a classic exam topic.
Yeah.
It's all about the difference between correlation and causation.
Right.
Just because two things happen at the same time doesn't mean one causes the other.
Give me an example. I feel like I've fallen for these tricky relationships before without even realizing it.
Imagine you're studying data and you notice that ice cream sales
Okay.
and crime rates both increase during the summer months.
Oh.
Does that mean eating ice cream turns people into criminals?
Okay. I can see how that's a ridiculous connection. There must be another factor involved, right?
Exactly. The hidden variable here is probably the warmer weather.
Okay.
Hot temperatures might lead to more people being out and about, which could unfortunately lead to an increase in crime.
Right.
Simultaneously, people crave ice cream when it's hot.
Yeah.
So there's a correlation,
Yeah.
but not a causal link.
That's such a helpful example. So how do we avoid falling into these spurious relationship traps
Yeah.
when studying or doing our own research?
The key is to always think critically and look for those hidden variables.
Okay.
Ask yourself, is there another explanation that makes more sense?
Right.
Don't jump to conclusions based on superficial connections.
It's like being a detective all over again. Now, speaking of building knowledge and forming theories,
Yeah.
let's talk about the research process itself.
Okay.
How do researchers go from observations to actual theories?
There are two primary approaches:
Okay.
inductive and deductive research.
Okay.
Think of them as two sides of the same coin.
Okay.
Inductive research starts with observations.
Mm-hmm.
You notice something interesting in the real world,
Right.
like a pattern or a trend, and then you develop a theory
Okay.
based on those observations.
So it's like piecing together a puzzle. You see the individual pieces, and then you try to figure out the bigger picture they create.
Precisely. Now, deductive research flips that process.
Okay.
You start with a theory, a general principle,
Mm-hmm.
and then test it using real-world data.
Right.
You're essentially putting that theory through its paces to see if it holds up under scrutiny.
Okay, so inductive is about building from the ground up, and deductive is about testing existing ideas.
Yeah.
Got it. But what exactly is a scientific theory? Is it just a random guess or a hunch?
A scientific theory is much more robust than just a guess.
Okay.
It's a structured framework with three key components.
Okay.
First, you have the assumptions, which are the fundamental ideas underpinning the theory.
Huh.
Second, there's a model, which you can think of as a map outlining how different variables relate to each other.
Mm.
Finally, you have hypotheses,
Yes.
which are testable predictions that emerge from that model.
Can you give us a concrete example to help illustrate this concept?
Sure.
It sounds a bit abstract.
Absolutely. Let's take public service motivation theory, or PSM theory.
Okay.
The fundamental assumption of PSM is that some people are inherently drawn to serving the public and making a positive impact.
Okay.
The model outlines the factors that contribute to this motivation, and the hypotheses might predict things like people with high PSM scores are more likely to choose careers in public service.
Ah, so you're not just saying some people like public service. You're actually breaking down why they might feel that way and then making predictions about how that motivation will play out in their career choices.
Precisely.
Okay.
And that's where hypotheses and variables come into play.
Okay.
A hypothesis predicts a cause and effect relationship between two variables.
Okay.
You have your independent variable, the factor that's causing the change,
Mm-hmm.
and your dependent variable, the factor that's being affected.
So in our PSM example, the level of someone's PSM score would be the independent variable,
Yes,
and their career choice would be the dependent variable, right?
spot on.
Okay.
Now remember, variables can be measured in different ways.
Okay.
Quantitative variables are numerical, like age income or test scores.
Mm-hmm.
Qualitative variables are categories,
Okay.
like personality types or job satisfaction levels.
Got it. So we've got our theories, hypotheses, and variables all figured out.
Yeah.
What's the next step in this research adventure?
Before you even think about collecting data,
Okay. You need to clearly define your research problem.
Yeah.
What are you trying to achieve with this study? Are you exploring a new phenomenon, describing something in detail, explaining a cause and effect relationship, or testing an existing theory?
So it's all about setting a clear destination before embarking on our research journey.
Exactly.
Okay.
Once you've determined your research aim,
Yes.
you can craft a laser-focused research question.
Right.
This question will guide your entire study and help you stay on track.
And this research question is basically at the heart of the study, driving all the decisions about how to collect and analyze data.
Absolutely.
Okay.
Sometimes your main research question might be broad,
Yeah.
so you can use sub-questions to break it down into smaller, more manageable chunks.
Right.
But remember, keep those questions concise and focused.
Okay, so far we've covered a lot of ground.
We have.
From the core principles of scientific research, like falsification, to the art of crafting a killer research question, it's a lot to take in. It is, but remember, understanding these foundations is crucial for acing those exams. It's not just about memorizing definitions.
Yeah.
It's about being able to apply these concepts to real-world research scenarios.
And don't forget, if you're feeling a bit overwhelmed or want to test your knowledge,
Yeah.
Grade Guru has got you covered.
Exact.
Head over to gradeguru.nl for in-depth explanations,
Yes.
practice exams, and a full summary of all these concepts.
Now, before we move on to the different types of research designs, take a moment to reflect.
Okay.
What's resonating with you so
Yeah.
far?
Yeah.
What's sparking your curiosity? What feels particularly relevant to your upcoming exams?
Good questions.
Yeah. It's amazing how all these concepts we've been talking about, theories, hypotheses, variables, come together to form a powerful system for understanding the world.
Yeah.
It's like constructing a building.
Yeah.
You need a solid foundation,
Right.
the theories,
Uh-huh.
a framework, the hypotheses,
Okay.
and the materials, the variables, to create a robust structure.
That's a great analogy. And just
Yeah.
like building a house requires a blueprint, research needs a solid plan. So let's talk about research designs.
Yes.
What are the different types?
Okay.
And how do we choose the right one for our research question?
Yeah.
This seems like prime exam material.
You're absolutely right. Understanding research designs is crucial for those exams.
Yeah.
There are several types, each with its own strengths and weaknesses.
Okay.
Let's start with experimental designs,
Okay.
where you have a high level of control over the variables.
Okay.
Think of a classic drug trial,
Okay.
where you randomly assign participants to either receive the drug or a placebo.
So in an experiment, you're really manipulating the situation to see what happens.
Right.
But isn't it sometimes impossible to control every aspect of a study, especially when dealing with real-world issues?
That's a great point. There are many situations where it's simply not feasible or ethical
Yeah.
to manipulate variables in that way.
Right.
That's where quasi-experimental designs come in handy. They're similar to experiments,
Oh.
but might lack random assignment to groups.
Can you give me a real-world example of when a quasi-experimental design would be more appropriate?
Imagine you want to study the impact of a new government policy on employment rates.
Okay.
It's not possible to randomly assign citizens to experience the policy or not.
Right.
So you might compare employment trends in regions where the policy is implemented to regions where it isn't,
Okay.
even though you haven't controlled the assignment of those regions.
Okay, I see the difference. It's still a structured study, but you're working with the reality of the situation rather than creating a perfectly controlled experiment.
Exactly. And then we have non-experimental designs,
Okay.
which are great for exploring topics where manipulation isn't possible or ethical.
Oh.
These designs include surveys, interviews, case studies, and observational research.
So if I wanted to understand how people feel about a certain political candidate, I might use a survey. But if I wanted to deeply explore the history and context of a specific social movement, a case study would be more appropriate.
Precisely.
Okay.
Each design has its own purpose and strengths.
Yeah.
Choosing the right design depends entirely on your research question and aim.
This is all starting to make sense, but no matter what design we choose,
Yeah.
we always need good data.
Yes.
Right?
Yes.
That's the fuel that powers the entire research engine.
Couldn't agree more. Data is the lifeblood of research.
Yes.
We need to ensure the data we collect is reliable and valid.
Okay.
Reliability means our measurements are consistent.
Okay.
Think of a bathroom scale that gives you the same weight
Yep.
every time you step on it.
So reliability is about consistency. But what about validity? What does that mean in the research world?
Validity means we're actually measuring what we intend to measure.
Okay.
If your bathroom scale is consistently 5 pounds off,
Yeah.
it's reliable, but not valid.
Right.
In research, we need to make sure our methods are truly capturing the concepts we're interested in.
It's like studying for the wrong exam.
Yeah,
You might do well on the exam, but it won't help you achieve your actual goal.
that's a great analogy. Now, careful planning, clear thinking,
Yeah.
and meticulous attention to detail are essential at every stage of the research process,
Right.
especially when it comes to analyzing data.
So it's not enough to just collect data.
Mm.
We need to know how to make sense of it. That's where statistical analysis comes in, right?
Absolutely. We need to choose the right statistical techniques to analyze our data and avoid drawing false conclusions.
Right.
It's a whole other world of knowledge,
Yeah.
but it's crucial for understanding research findings and critically evaluating studies, which is super important for your exams.
This is feeling a bit like detective work.
Yeah.
We're gathering clues, analyzing evidence, and trying to solve the mystery of our research question.
I love that comparison. And just like a good detective,
Yeah.
researchers need to be observant, skeptical, and always open to new information and different perspectives. Speaking of perspectives, let's shift gears and talk about generalizability.
Okay.
Can we apply the findings of our study to a larger population or a different context?
So just because a study shows a particular drug is effective in a small clinical trial
Right.
doesn't necessarily mean it will be effective for everyone in the real world.
That's right. We need to be cautious about making sweeping generalizations
Okay.
based on limited findings.
So how do we know if a study's findings are generalizable.
Yeah.
What should we be looking for when evaluating research, especially for exams?
There are several things to consider.
Okay.
First, look at the sample size and how representative it is of the larger population.
Right.
A small, non-diverse sample might not reflect the broader reality.
Right.
Second, consider the context of the study.
Okay.
A study conducted in a controlled lab environment might not generalize well to real-world settings.
So it's about looking beyond the surface level findings.
Yeah.
And critically evaluating the methodology, the sample, and the context.
Right.
It sounds like critical thinking is the key to success in both research and exams.
Absolutely. Remember, research is an ongoing process.
Yeah.
One study rarely provides definitive answers.
Yeah.
It's about building on existing knowledge, challenging assumptions,
Right.
and constantly seeking a deeper understanding.
This has been incredibly helpful.
Yeah.
We've covered so much ground, from the foundations of science to the nitty-gritty of research designs and evaluation. I feel much better prepared for those exams already.
And we've only scratched the surface. But don't worry, if any of these concepts have sparked your curiosity, or if you're hungry for more practice, remember that gradeguru.nl has a treasure trove of resources to help you delve deeper.
Okay.
You'll find detailed explanations, practice quizzes, and even a full summary of everything we've discussed today.
Grade Guru is a lifesaver. Now, before we wrap up this section, I want to touch on something that's been swirling in my mind. We've talked a lot about objectivity and rigor in research, but can we ever truly be objective?
That's a good question.
Don't our own personal experiences and perspectives inevitably influence how we approach research?
Yeah, that's a question that has puzzled philosophers and scientists for ages. It reminds me of that saying, we don't see the world as it is, we see it as we are.
Right.
So how do we reconcile the pursuit of objectivity with the reality that we all have unique lenses through which we view the world?
That's such a crucial point, and it brings us to the concept of paradigms.
Okay.
A paradigm is like a mental framework,
Okay.
a set of shared beliefs, values, and assumptions that shape how we see and interpret the world.
So different researchers might approach the same topic with completely different paradigms,
Yeah.
leading them down different research paths and even influencing their conclusions.
Absolutely.
Hmm.
Imagine studying poverty.
Okay.
A researcher with a purely economic paradigm might focus on income levels and job statistics.
In contrast, a researcher with a social justice paradigm might consider systemic inequalities and historical oppression.
That's fascinating. It's like looking at the same painting but noticing completely different details.
Yeah.
Depending on your background, knowledge, and perspective.
Precisely. And it's important to remember that no single paradigm is inherently right or wrong.
Right.
They just offer different ways of understanding the world, each with its own strengths and limitations.
Okay, so awareness of these different paradigms is key, especially when evaluating research.
Absolutely.
How can I, as a student prepping for exams, make sure I'm considering these different perspectives?
When you're reading research articles or studying different theories, try to identify the underlying paradigms at play.
Okay.
Ask yourself, what assumptions is this researcher making?
Mhm.
What values or beliefs are shaping their approach?
That's such a helpful tip. It's like adding another layer of critical thinking to my study process. It's not just about absorbing information, but also understanding the context and the potential influences on that information.
Exactly. And it's also about being open to challenging your own paradigms.
No.
Be willing to consider alternative perspectives, even if they clash with your initial assumptions.
Right.
That's how we grow our understanding and become more informed and discerning thinkers.
This whole conversation about paradigms and perspectives has been a real eye-opener. It's
Good.
making me realize that research is much more nuanced and multifaceted than I initially thought.
And that's the beauty of scientific inquiry. It's a continuous journey of exploration, questioning, and refining our understanding of the world.
Yeah.
It's not about having all the answers.
Yeah.
It's about embracing the process of discovery.
I love that. It takes the pressure off of needing to be right all the time, and instead encourages curiosity and a willingness to learn and adapt.
Exactly. And that mindset is essential for success, not just in your exams, but also in your future careers and life in general.
This deep dive has been incredibly valuable.
Good.
We've explored the foundations of scientific research, from falsification and spurious relationships to research designs, data analysis, and even paradigms. I feel much more equipped to tackle those upcoming exams.
And remember, if you're feeling stuck or want to put your knowledge to the test, Grade Guru has your back.
Yes.
Visit gradeguru.nl for practice exams, detailed summaries, and a wealth of resources to help you master these concepts and ace your exams.
Grade Guru is a true exam prep hero. Now, before we wrap up, I want to leave our listeners with one final thought.
Okay.
As you continue your learning journey, remember to approach information with a healthy dose of curiosity, skepticism, and humility.
Those are wise words.
Yeah.
Curiosity to explore new ideas,
Yeah.
skepticism to question assumptions,
Mm.
and humility to acknowledge that we don't have all the answers.
Beautifully put.
Yeah.
And remember, research is an ongoing conversation, a collaborative quest for knowledge that's constantly evolving.
It is.
Embrace the journey, stay curious, and never stop learning.
That's a perfect note to end on. Thanks for joining us on this deep dive into the fascinating world of scientific research.
Until next time, keep those brains buzzing, happy studying, and good luck on those exams.